So now we're going to take up some of the problems on intermediate structural problems. The problem number 13. A BCD is a vertical rigid bar. It is supported by steel wires BE and copper wire CF and pin jointed at capital A, which is as shown in this figure. A vertical load of 12 kilonewton acts at D. Determine the stresses produced in steel and copper wire and the deflection at the free end B. So given area of cross section of the steel wire is 400 mm square, area of copper wire is 600 mm square, and having the Young's modulus of steel as 2 into 10 to the power of 5, and EC is equal to 1 into 10 to the power of 5 Newton per mm square. Now, we'll continue with the figure which is having one end is fixed here, wherein you have the steel wire having the length of 250 mm and copper wire having 400 mm is placed at a distance of 200 mm from the A, and also the copper wire is at 500 mm from the point A, and the load of 20 kilonewton which is acting at the point D, which is at 200 mm from the copper wire. So this is the structure, and the deflections what you will going to get at the steel wire, which is delta S, and PC, which is at the copper wire, which is going to be delta C, and here the deflection what you are going to get is delta D. It is acts like a cantilever beam. As the load is acting from the upward direction, from the top towards the downward direction, the bar will going to bend in this particular position. This is the final position. Due to that, so as it is acting downwards, in order to keep it in equilibrium condition, the force will going to act in the upward direction, so which is PC here, and also the PS, which is also acting upwards, because the beam is trying to bend in the downward direction in order to keep the body or the beam in the equilibrium condition. So now, stress produced in the steel and copper wire. So the stresses produced in the steel and copper wire we need to find out. So from the above figure, which shows the position of the rigid bar after the application of load. Let delta S is the deflection of the steel wire, and delta C will going to be the deflection for the copper wire, and delta D is the deflection at the free end, capital D. From the principles of similar triangular principle, so what we are going to get? So delta S by 200 will be equal to delta C by 500, that is equal to delta D by 700. So how do I know? So from the similar triangles which we are considering, so delta S by 200, which is AB, and delta C, which is AC, which is 500, and delta D by 700. So because AD. So that is how you will be able to take the similar principles. That is, this adjacent, this is the opposite side by this adjacent side, and this opposite side by this adjacent side, and this opposite side by this adjacent side. So that is how it will going to be from the similar triangular principles. So once you get that, then that is delta S by 2 will be equal to delta C by 5, that is equal to delta D by 7. So what is delta C? If you consider delta C 5 by 2 into delta S, so 2.5 into delta S, and similarly delta D will be equal to 3.5 into delta S. So you are expressing the deflection of the point C and D in terms of delta S. That's all. So once you do that, so what will going to be the deflection of delta S? That is, if you are considering this delta C, what is delta C? Delta C is nothing but P into LC by AC into EC, or PC into LC by AC into EC. That is equal to 2.5 into PS into LS by AS into ES. Similarly, as PC into LS is the length is 400 divided by 600, that is area of cross section, into EC, that is the Young's modulus of the copper wire, will be equal to 1.2 into 10 to the power of 5. This is as per the data given. You substitute those values. that is equal to 2.5 into PS into 250 by 400 into 2 into 10 to the power of 5. So therefore, the value of PC in terms of PS you are going to get, which is 1.40625 into PS. So similarly, taking the moments about the point A, once you are taking the moments about the point A, so sum of the clockwise moment will be equal to sum of the anti-clockwise moment. So what will going to be the value? PS into 200 plus PC into 500 will be equal to 12 into 700. So that is because if you are considering this, if you want to see that, we have to go to this figure wherein taking the moments about the point A. So what is that? The stress, the load which is acting upward direction, sum of the clockwise moments will be equal to sum of the anti-clockwise moment. So PS load into this perpendicular distance is PS into 200 plus PC into 500. So that is 300 plus 200, PC into 500, which will be equal to 12 into 300 plus 200 into 200, 300 plus 200 plus 200, which becomes 700. So that is how we will going to be able to taking the moments about the point A. So on simplification, you are going to get it PS into 2 plus PC into 5 is equal to 84 mm. So once you get this, so you know PS into 2 plus PC, what you know the value of PC as 1.40625 into PS, that we have calculated that value, multiplied by 5 will be equal to 84. Therefore, PS tension in the steel wire you are going to get, which is PS, will be equal to, on simplification, you are going to get it as 9.3 kilonewton. So what is the tension in the copper wire? The tension in the copper wire PC will be equal to 1.40625 into PS. So 1.40625 into PS value is 9.3. So that will be equal to, on simplification, you are going to get it as 13.08 kilonewton. So what is the stress induced in the steel wire? The stress induced in the steel wire is PS equals, sigma S will be equal to PS by AS. You know the value of PS, which is 9.3 into 10 to the power of 3 by area of cross section of steel wire is 400. So on simplification, you are going to get it as 23.25 Newton per mm square. Similarly, stress induced in the copper wire sigma C will be equal to PC by AC, which is equal to 13.08 into 10 to the power of 3 by 600, which will be again equal to 21.8 Newton per mm square on simplification. So this is how you will be able to find out the stresses. Now what will going to be the deflection at the free end? The deflection at the free end, which is deflection of the steel wire, which is delta S, will be equal to PS into LS by AS by ES. So sigma S into LS by ES, because PS by AS is sigma S. So into LS by ES. So you know the value of stress, which is 23.25 into length of the steel wire is 250 by Young's modulus of steel wire, which is 2 into 10 to the power of 5. So on simplification, you will going to get it as 0.02906 mm. Similarly, deflection of the copper wire delta C will be equal to PC into LC by AC into EC, or sigma C into LC by EC, or otherwise you know delta C will be equal to 2.5 into delta LS. We have already calculated the value of delta S, so you substitute those values, 2.5 into 0.02906, which is going to be 0.07266 mm. So deflection at the free end delta end D, delta LD will be equal to 3.5 into delta LS. The delta LS here, what we are talking about is delta S. So 3.5 into, substitute that value of 3.5 into 0.02906. So on simplification, you will going to get it as 0.10172 mm. So this is how you will be able to solve this problem on this problem number 30. And we have found the stresses and also the deflections of the free end we were able to calculate. Thank you.